Hello everyone. In this video, we're going to be integrating a product. We have e to the power x multiplied by cosine x dx, and we're going to integrate this function. How do you integrate this? Well, when you don't know what to do, you can either use u substitution if that works, great, or maybe you can try integration by parts, which is the following. Let me give you the formula real quick. Whenever we have something like u times dv, this becomes u times v minus the integral of v times du. U and v are just functions of x. Why does this work? If you put this on the left-hand side and differentiate both sides, you're basically going to get the product rule. So that's where that comes from. Make sense? Easy. Now, let's go ahead and use integration by parts. We need to determine which one is u, which one is dv. So here's some principles that can help you, some guidelines. Well, if you're going to pick u, you are looking for something easy to differentiate. And for dv, it should be something easy to integrate. Of course, there are exceptions. Like, for example, if you have ln x dx, ln x is not necessarily easy to differentiate, but harder to integrate. Dx is kind of easy. I don't know. And most of the time, when you have a polynomial multiply by e to the x, or polynomial times sine x or cosine x, it's usually the polynomial that becomes u, because you can easily differentiate it. You know, at some point it becomes 0. And the other function is, well, sort of easy to integrate, right? Kind of. So here's what we're going to do then. We're going to go ahead and call this u and call this dv. I mean, what else can we do, right? Can you do the opposite, like call this u, maybe? Give it a try and let us know how that goes. So let me go ahead and write it down. I'm going to show you a systematic way to write it so you don't get it wrong. So u equals ex, and this implies du equals e to the x dx. So to find the du from u, you need to differentiate. So this way, from u to du, the d stands for differential, okay? So you differentiate. But of course, don't forget the differential of x, that infinitesimal thingy, right? And then underneath that, go ahead and write down dv, which is cosine x dx. Notice that we're going to integrate to find v, but don't include the constant because we're going to add that at the end. Make sense? There's no point in adding constants all the time because constant plus a constant is another constant. Okay, it's still a constant. So how do you integrate cosine x? You should know that the integral of cosine is sine, because the derivative of sine is cosine. Don't get confused. Sine, cosine, if you integrate, it becomes sine. If you start with cosine and differentiate, you get a negative sign. Be careful about that, okay? Make a chart, make a table, and hopefully you'll get it right. So where do we go from here? We're going to go ahead and kind of go this way. Start here. Remember, we have to do uv. So we're going to go from this to that one, and then from that one to this one. But there's a minus sign here that you need to put in between. Make sense? So here's how it goes. E to the x cosine x dx is equivalent to uv, which is e to the x sine x, minus the integral of v du, which is e to the x sine x dx. Nice. I want to write the e to the x first. You know why? Because we're going to use integration by parts again. Why? Because we have to. We got something similar, right? Wait a minute. Is this going to work at all? You'll see in a little bit how that goes, because I think the answer will be very interesting, especially the solution method. Even though it looks like integration by parts, wait till the end, okay? Now, we got our integral, original one, but we got another integral. So now we need to integrate this. And then once we do, we can go ahead and plug it in. So let's go ahead and do that. I'm going to integrate this as if I didn't know the original part. And to do that, we're going to use the same thing. And can we just reset the u and dv and use it again? Because I don't want to use other variables. Doesn't make sense. We have to stick to d, v, and u. So now u is e to the x again. That means du is e to the x dx. dv is sine x dx. Here, be careful. What is the integral of sine x? Is it cosine? No. Because the derivative of cosine is negative sine, so the derivative of which function is sine? That's the question you need to ask. The answer is negative cosine. Make sense? And you can always check. There's no dx here because we're just integrating, okay? The next thing is going from this to this and then from that to this, but don't forget to put a minus sign in between. Wait a minute. We have now this, right, equals uv, which basically makes a negative sign, right? Yeah. And then, okay, uv minus v du. Now notice that there's a minus sign and v is negative, so that's going to make a positive, right? And that'll be cosine x dx. Nice. So this gives us the following. We know how to integrate cosine, don't we? Yay, we can do that. Easy. Okay. Now let's go ahead and write integral of e to the x sine dx. E to the x sine x dx is negative e to the x cosine x plus sine x. Right? Okay. What are we going to do now? So we're going to go ahead and actually we made a mistake. Sorry about that. Let's go back here and fix this because it was supposed to be v du. Okay, minus turns into a plus sign. V du, that will be e to the x cosine x dx. Awesome. So that's the answer. Obviously, it wouldn't be that like that, right? So now what is going on here? Well, that is e to the x sine x. Let's go ahead and copy that or move it. Let me clean this area first. Then I'm going to move this up so that we can kind of put those two together. Now we can go ahead and move this guy over here. Oops. And then we can kind of move it up, scroll up, and bring it as close as possible. Okay, here we go. I think this is good. Awesome. And then we can delete it when we don't need it. So now this is e to the x sine x dx. E to the x sine x dx. So let's go ahead and substitute this here. Notice that there's a minus sign, so this is going to be another minus sign. So the integral of e to the x cosine x dx equals e to the x sine x minus this expression inside the box minus e to the x cosine x plus integral of e to the x cosine x dx. Uh-oh. Houston, we have a solution. Okay, what is going on? Let's go ahead and negate. We get the integral of e to the x cosine x dx equals e to the x sine x, double negation, plus e to the x cosine x, minus the integral of e to the x cosine x dx. What is going on here? Well, we're going to go ahead and put this on the left because we have the same thing. When you add something to the same thing, like the same thing to the same thing, you get 2 times that. I mean, some people are going to call this integral I, because I for integral, but that's not necessary. You can just add like terms, right? You like that? And here we can factor out an e to the x and write this as sine x plus cosine x. Now, don't worry, I didn't use the constant term, but I'm going to go ahead and use it at the very end. Now, what are we going to do? We're going to divide both sides by 2, and guess what? That's going to give us the answer. You know what this is called? This is called solving without solving. And that happens sometimes. So this is a very, very special integral. And of course, that's the integrand, the result, plus the constant c. Now, you can check your work by differentiating the answer. We can go ahead and do that if you want. Take this expression. If you differentiate, the expression on the left, Take this expression, and don't worry about the c because its derivative is 0, and differentiate it. The derivative of e to the x multiplied by sine x plus cosine x, and then the derivative of sine x plus cosine x, which is cosine x minus sine x, times the first function e to the x, all over 2. When you factor out an e to the x, you get sine x plus cosine x minus sine x, all over 2. And then from here, you get 2 cosine x and 2 cancels out. You end up with cosine x, e to the x, and that will be the original stuff that we started with. Bingo, it checks out. So we're done, and this brings us to the end of this video. Well, thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.